In the next 5 minutes, I hope you learn something new about completing the square. In the exam, you'll be asked something like, put the expression x squared plus 6x minus 11 in the form x plus p squared plus q, where p and q are integers to be found. In other words, we have this expression, but they want us to write it in a slightly different way, with a number inside the brackets and a squared and a number outside the brackets. Let's see how we do that. First step is you half the number next to the x. Not the number next to the x squared, not the number on its own, just the number next to the x. That would be plus 3. Half of plus 6 is plus 3. You then put that inside a bracket along with the x. So it's now x plus 3. At the moment, we don't know why we're doing that, but we'll see in a very short while. We then times out this bracket. How do we times out a bracket like that? We would write it next to itself, because after all, squared just means times by itself. X plus 3 squared is x plus 3 times by x plus 3. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. X squared plus 3x plus 3x plus 9. Collecting like terms, we would get x squared plus 6x plus 9. Notice how, because we halved the number next to the x, we ended up with something very similar to what we started with. We halved the number next to the x, we squared it out, and that meant, because there was two of them, notice a 3x and a 3x, we got back to what we started with. So we halved the number, but then there was two of them, so we're back to where we started with. We also got the x squared, which is something else we started with. The only thing we didn't get that was the same as what we started with was the plus 9. Let's make a comparison between plus 9 and minus 11. So far, this expression, which we've got, x plus 3 squared, is, as you notice, very similar to what we started with. We've almost put it in this form, but not quite. How do you get from plus 9 to minus 11? To get from plus 9 all the way down to minus 11, you would have to take away 20. You have now completed the square and put it in the form x plus p squared plus q. P is the plus 3, notice the similarity, and q is the minus 20. That's very useful, by the way, for all different types of mathematics. It's useful for drawing graphs, it's useful for solving equations, but in this video I just wanted to show you how to do it if the exam asks you a question like this. Let's try another one. This time they're asking you to do the same thing, put it in that form, but the expression is a little bit different. Notice, by the way, that in both expressions you can't factorize. You couldn't factorize this expression with a minus 11 at the end, and you can't factorize this. What do we do first? We half the number next to the x, so it's now going to be x minus 5. The number one mistake I see students making is that they write inside the brackets x minus 5x. So they bring in another x to join in the bracket. I know being in the bracket is kind of fun, but it's only allowed for the number. The other x just has to stay outside. So it's just x minus 5 squared. To cut a long story short, you only half the number, not the whole thing. So it's minus 5. Let's times out the bracket. Well, I know straight away when I times out that bracket, I'm going to get x times x, which is x squared. I'm going to get x times minus 5 twice, so that's going to be minus 10x. And then I'm also going to get minus 5 times minus 5, which is 25. We have an x squared and an x squared, which is good. a minus 10x and a minus 10x, which is great. And that will always happen, to be honest. Whenever you halve the number, you'll always get back to almost what you started with. But we have a plus 25 and we wanted a plus 17. How do we get from the plus 25 to the plus 17? We would have to minus, what is it? You'd have to minus 8. And there we have it. We have completed the square. P would be the minus 5 and Q would be the minus 8. One quick final example. I'm going to go super fast for this one. Let's imagine we have the expression x squared plus 2x minus 1. Let's complete the square there. Halving the 2, you get 1. So it's x plus 1 inside the brackets. Squaring that out, we're going to get x times x, which is x squared. We're going to get a 1x and then another 1x, giving us 2x, which is exactly what we started with. And we're going to have a 1 times a 1, which is a plus 1. Almost the same as what we started with, but with one difference. We don't want plus 1, we want minus 1. So what do? We need to minus 2 to get from plus 1 to minus 1. So there we have it. We have completed the square. Finally, I just wanted to show you why it's called completing the square. Let's take that last example. Let's see if I can fit in a little square. Okay, this is a rectangle, but you get the idea. Let's do some sections like so. There we have it. What is x times x? It's x squared. And then 1 times x is 1x. And 1 times x again is another 1x. But with completing the square, we needed to find that number which gets us from what this bracket gives us to what we started with. In this case, the number was minus 2. That brought us from the brackets to what we started with. And by finding that number, we have completed the square.